This for quadratics. So we're talking about quadratics. We have something with the x squared. So this is kind of your basic parent function that you need to memorize, just like you memorized the absolute value parent function. You knew those 5 or 7 points, and you need to know these 5 points as well. If you want to just derive those points from scratch, if you didn't want to memorize them, I guess you could. You could just plug in values like -2, -1, 0, 1, and 2 for x, and plug them into the function y equals x squared. So everywhere there's an x, you're going to plug in those values. So 2, that would be 2 squared is 4, 1 squared is 1, 0 squared is 0. -1 squared is actually, when you write it like this, -1 squared is equal to +1, and -2 squared is equal to +4. So you square a negative, it becomes positive. So you can see these 5 points that are listed in the table that I'm highlighting right now in blue. Those are the 5 points you want to memorize. I guess, well, these are optional. Like, you don't have to memorize those two. But these 5 points right there, you want to know those just by heart. Know them, because when you transform A like we did with absolute value, you'll have to write out those 5 points, multiply the y values by whatever A is. So the formula is very similar. So the H, in fact, functions transform the same way. So if you understood how functions transform with absolute value, you are going to understand how functions transform with parabolas. So H is going to move it right or left. You want to say how many, in which direction. K is going to move it up or down. By the way, H is always opposite of what you think. If it's minus, it's going to move it to the right. Plus is going to move it to the left. A does a couple things. So if A is negative, it's going to reflect across the x-axis. If A is bigger than 1, it's going to be a vertical stretch. If A is smaller than 1 but bigger than 0, like a fraction like 1/2, that's going to be a vertical shrink. So the same transformations that we've done in the past work this way with parabolas. So you could start this way by graphing the 5 points we know and love. So you can go 0, 0, 1, 1, 2, 4 for a parabola, for a quadratic, and -2, 4, and -1, 1. So those are your 5 points that you have memorized. And now we're going to move those 5 points according to whatever transformation is happening. So H, that's an H value, that's a right or left. And adding 2 will actually move it to the left 2. So that, if you want to say it in words, in transformation talk, it'll be left 2 is what the transformation, it's only one transformation happening with this function. So every point moves 2 to the left. That point moves 2 to the left. That point goes 2 left. The vertex goes 2 to the left. That's the vertex. This one goes 2 to the left, and this one goes 2 to the left. And pretty soon you're going to draw your parabola as best you can. It doesn't go straight up. You notice it's going a little bit to the right and up, a little bit to the left and up on those 2 points. So don't draw it straight up. Sometimes students will draw it like, straight up there, and it doesn't actually do that. It's going to be kind of a U shape, and so it's getting steeper and steeper as it goes up, but it's not going straight up ever. That would not be a function, right? You can't have 2 points vertical from each other. So it's going slightly to the right there on the right and slightly to the left as it goes up faster and faster. And that's your graph of your function. Okay, let's try this transformation. So if you think about, so first start with your parent graph, start with your points, 5 points you know and love, 0, 0, 1, 1, 2, 4, -1, 1, and -2, 4. So those are your 5 points that we know. And then we're going to transform them somehow. In this case, this looks like it's outside the parentheses. If there was a parentheses, like the formula is y equals a times x minus h, there doesn't seem to be an h there. Right? It's like x minus 0 squared. So it's not moving right or left at all. It is moving, in this case, down 3. So you'd say in words, down 3. So you're taking each point and moving it down 3. So this is, once you've had transformations, and this book does a really good job, this particular book does a good job of like just kind of helping students to understand transformations. If you're interested with absolute value, this lesson is going to be easy for you because we're doing very similar stuff here. In this one case, let's say it in words. So when there's a negative in front of the function, that is going to cause a reflection across the x-axis. So that's the transformation words. Start with your 5 points you know and love, 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. And we're going to transform that by, so this is a case where, I guess I'll just show, so I would, every time A is something other than 1, just go ahead, get in the habit of writing out those points. So 0, 0, 1, 1, 2, 4. And then your points to the left, negative 1, 1, and negative 2, comma, positive 4. And so for the transformation, since A is actually equal to negative 1 there, right? A is negative 1. We're going to multiply all the y values by negative 1. Well, that stays 0. Now it's negative 1. Just changing the sign. Now it's negative 4. Now it's negative 1. Now it's negative 4. So to plot those 5 points, so 1, negative 1 is here. You can see that point moved. It reflected over the axis. 0, 0 is actually the same point. Negative 1 is now here. Positive 2, negative 4 is down here. It reflected over the axis, and that point also reflects down. So the whole thing just now goes down and to the right, and then down and to the left. And you've got your parabola. It should be nice, a little smoother than that. I kind of made it like a V. It's a curved shape there. It's hard to draw on the smart board, especially. Yeah, we'll probably do a better job. Parabola has a curved look to it, kind of like a U more than a V shape. Again, I made that a little TV-ish there. So try to make it curved. It's definitely not going to be a linear line. It's curved. Okay, so again, anytime these values are not, A is not 1, get in the habit, like in this case, the A value is 2 there. So I'm going to write out my 5 points I know and love, 0, 0, 1, 1. Again, you got to know these are different points than the absolute value points that you memorized. Some of them are the same, actually, which is interesting. But most of them are different, so negative 2, 4. Okay, so we're going to multiply all the y values by 2, which should be called, in words, it's called a vertical stretch. Vertical stretch. That's the name of that transformation. So multiply 0 by 2, well, that's still 0. That's 2, that's 8, that's 2, that's 8. Some of these are going to be hard to fit on the screen here. So 0, 0, 1, 2. 2, 8 is somewhere, wow, like way up there. I don't know, somewhere up there. It's hard to say. Negative 1, 2, negative 2, 8, somewhere way up there. It's like hard to graph. So this is a very skinny parabola, right? It's coming up very quickly. So that stretch, that vertical stretch, made it go up a lot quicker than it would have without the stretch. So it makes it kind of skinny. Again, we have an A transformation. The A value is not 1, so I would write out your ordered pairs here. So this would be 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. And all the y values are being multiplied by negative 1/2. That's called, so there's two transformations there. That's a reflection over the x-axis because it's negative. It's also a vertical shrink. It's going to make it wider or fatter here. So I'm going to multiply all the y values by negative 1/2, and that should actually change everything for us. So that'll be now negative 1/2. That'll be negative 2, negative 1/2. Sorry, this is really sloppy, and negative 2. So I'm going to plot those points, 0, 0. It's hard to plot that point. 1, negative 1/2 looks like about here. 2, negative 2 is a little easier. It's not bad. And negative 1, negative 1/2, and negative 2, negative 2. If you want to do one more, like the normal point would be like 3, 9. So you multiply by that by negative 1/2, that would be negative 4.5. That'll actually fit on this one. So like 3, negative 4.5 is right about there. And negative 3, negative 4.5 is about there. If you wanted to plug those extra points in, but 5 points would be enough. I wouldn't mark it down. Just make sure it looks curved. It should not be straight like the absolute value graph was, and that looks okay there. This one, again, since a is not equal to 1, just get in the habit of writing out the points you know and love. Since a is 1/3, we're going to multiply all the y values by 1/3. So 0, 0, 1, 1, 2, 4. Make sure you're not doing absolute value, negative 1, 1, and negative 2, 4. You're doing our parent graph. Make this one right here. So all the y values are going to be multiplied by 1/3. That's called a vertical shrink. So it's going to be 0, negative 1/3. I guess that would be 4/3 or 1 1/3. 1/3. It's positive 1/3 there. I don't know why I put negative. 4/3. It's going to be a little harder to graph just because, okay, so 0, 0, 1 comma 1/3, right about there, I guess. 2 comma 4/3, right about there-ish. Something like there, about there. You've got 5 points. It's a really wide parabola. So that would be good enough there for that one. Okay, so let's put it together. These are just some basic ones. So you want to say it in words first. This is going to the right 4. So right 3, sorry, 3. And this one goes up. So up 1. So you take your 5 points you know and love. So 0, 0, 1, 1, 2, 4. And we're going to move those to the right 3 and up 1. So this vertex goes to the right 3 and up 1. That's my new vertex there. To the right 3, up 1. To the right 3, up 1. To the right 3, up 1. And to the right 3, up 1. So I've got my parabola. Go and draw it. Another thing to do that might help you, if you think about your formula, y equals a times x minus h squared plus k. So some people like to follow the vertex. They'll graph this just by following the vertex and kind of knowing your basic parabola form. Here's what I mean by that. So they'll figure out h is like, if you see the pattern here, x minus 3. H is definitely 3. K is definitely 1. So they'll actually just plot the point 3, 1 to start with, like 3, 1 is my vertex. And if you know the pattern for absolute value, or for y equals x squared, here's what I mean. If you look at this pattern for the very first, the parent graph, you're going up 1, over 1, and up 1 for that first point. So that's 1, 1, over 1, and up 1 for the second point. Starting at the vertex, you're going over 2, up 4. You're going over 2, up 4 the other direction as well. So 1, 1, and 2, 4. If you know that pattern really well, some people graph this by going, okay, go up over 1 to the right and up 1, over 2 to the right and up 4, over 1 to the left and up 1, over 2 to the right and to the left and up 4. That pattern remains even though it was shifted right or left or up or down. The pattern of the quadratic is going to be the same. And when it's negative, that pattern would just be reversed. So it would be 1 to the right and down 1. So when, like on the next one, it's going to be reversed there. So let's try it that way, just for a change here. So let's try to graph it. So let's try to identify the vertex first. So the vertex will be x minus h, so that'll be negative 1, the opposite of what you think inside the parentheses, and outside is exactly what you think. So you could actually plot the point negative 1, 2 as your vertex right away. That's your vertex. This is one way of doing this graph. And then if you know your pattern, this is opening down, so it reflects on the x-axis, so it's going to open down. So instead of going over 1 and up 1 to the right, it's going to go over 1 and down 1, over 1 the other way and down 1, over 2 from the vertex to the right, and then down 1, 2, 3, 4, over 2, down 1, 2, 3, 4, and you have your graph. That's kind of a fast way of doing that. The slower way of doing that, which is perfectly fine to do, is first write out the 5 points. Multiply all the y values by negative 1. In this case, like 0 remains the same. That's going to be -1. That's -4, -1, -4. You could plot those 5 points. Looks like this. And then you can move each one of those points to the left 1 and up 2. So each point goes left 1, up 2, and it gets to there. Left 1, up 2, left 1, up 2. I think I messed up that other one. Oh, I messed up those points. Sorry, these points should have been here and here. I didn't count them right. Sorry about that. So over 1, up 2 is right there, and over 1, up 2 is right there. So you get the same 5 points doing it that way. But again, it's just a different way of doing it. So let's look at this one. In words, you would say that this one has a vertical shrink and it's going down 2 units. So let's just do it the old-fashioned way. So 0, 0, 1, 1, whoops, 2, 4, -1, 1, and -2, 4. All the y values are multiplied by 1/4. We get 0, 1/4, 1, 1/4, 1. You got to go to the plot. 1/4 is about there. 1 is there. -1/4, 1. So you've got your 5 points, and now all 5 of those points are going to move down 2 units. So that one is outside the parentheses after the x, so it's moving it down, not left or right. So every point moves down 2. That one moves down 2. That one moves down 2. It's hard to move those other points, but somewhere around there. And you've got enough to make your beautiful graph. 5 points is enough to make a graph. Okay, so let's work backwards here. So identify the vertex. I would write it out. This is going to be 2, 3. The pattern seems to be, the same as the normal pattern that we know, except it's opening down. So right away, I know there's a negative in front. It looked like it moved to the right. So from 0, 0 to a vertex of 2, 3. So it'd be x minus h, which is 2 squared, plus 3, because it moved up 3, and you got your equation. You could plug in if you wanted to. So what I mean by that is you could plug in, that's your h and k. It's another way of doing this. Pick out one of the points, like that would be like 1, 2 would be like your x and y. Plug in your y, so y equals a times x minus h squared plus k. You could plug in, you already knew that, in parentheses. Okay, so you could plug in everything except for a and solve for a. So plug in your x and y, plug in your h and k, and solve that one for a. That's another way to do it if it's kind of a tougher one. Maybe a is something other than 1, which would make it difficult. Almost done here. So transformation. So this one would be a reflection across the x-axis. This one is going to move it to the right 2, and this one is going to move it down 1. So say all those things in words, and you got it. And write the equation in vertex form. So this one, this is what I was talking about. This is what you do. So this is your h and k because that's your vertex. This is just a generic point in there. That's your x and y. Plug into this equation and solve for a. That's basically what we're going to do. So instead of y, we're going to plug in -1. A, we don't know. X is 0 minus k. H is 1. plus k, which is negative 2. So I'm just going to solve this equation here and see what happens. So negative 1 squared is actually 1. So I get negative 1 equals 1 times a, or a, minus 2. Add 2 to both sides, I get 1 equals a. So now I know the a value is 1. So my equation, to write my equation, all you need is a, h, and k, and you should be able to write your equation. And we certainly know all of those right now. So I'm going to go ahead and write my equation. So it'd be y, you need a y in the equation, in other words, equals 1 times x minus h is 1, so x minus 1 squared, plus k, which is minus 2 plus negative 2. And you can write your equation. That's your lesson for today.